Transverse stationary wave. We are going to study the stationary waves in a string, and in a string always transverse stationary waves are produced. Both the ends of the string are stretched, they are tightened at the two ends. Before you go into detail, you must know what is linear density, because velocity of transverse waves is given by this relation V equal to root T upon m. M is known as linear density, that is mass per unit length, mass of the wire per unit length. Mass is volume into density upon L. Volume could be written as area into length into d upon L. So, you have to remember this linear density is also equal to area into d, or you might say pi r square into d. This is what we call linear density. While using this relation, you must be aware of this linear density. Then, if you are trying to fix the two ends of the wire, obviously, you will be having node at the two ends. As in the case of open organ pipe, we always had the antinodes at the two ends. Here we would say that nodes are there always at the ends. Between two nodes, it is going to be lambda by 2. Between two nodes, definitely there is going to be one antinode. Antinode means the maximum displacement and node the minimum. So, this is the minimum possibility, that means the lower frequency possible would be corresponding to this case only. Here you know the length is going to be lambda 1 by 2, that by lambda 1 becomes 2L, and frequency will be V upon lambda 1, that is 2L. Now, if you want to write replace this V by root T by M, you get final relation for fundamental frequency or the first harmonic. It is going to be 1 by 2L root T by M. Since it could be compared quite clearly with the open organ pipe, the next frequency that you are going to get 2N1, that is second harmonic. In this one, you are going to get all the harmonics odd and even, unlike closed organ pipe. In closed organ pipe, you know, you have only odd harmonics possibility, but here in the case of open organ pipe and this stressed string, you always have the possibility of all the harmonics odd and even. So, N2 is going to be 2N1, this is the first overtone and second harmonic. Likewise, N3 is going to be third harmonic and second overtone. N8 will be here 8N1, that is 8th harmonic and 7th overtone. Let us generalize it. If you want to write down or note down pth harmonic, that means you will write there Np. This is equal to P upon 2L root T by M. One thing is noticeable here is, if you are writing here 3, this is third harmonic, you are writing here P, it is pth harmonic. One clear thing is that in the first harmonic, you are having only one loop, and that loop's completion is quite apparent here. It is second harmonic, means it is obvious that there must be two loops. So, number of loops are clearly indicating the number of or serial number of the harmonics produced. Then, in numerical problem, there are many variations, because this M could be written as mass per unit length. This could also be written as A into D. Then this could also be written as pi square D. Since it could be written in various ways, we have so many possibilities of numerical problems and their twisting as well.